Hello and welcome to another video from Flash Jazz Cat, and here we have a frequent visitor to my house. It's an Atari 130XE. It's a very nice Atari 130XE, but this is its fourth visit to my house, unbelievably. As you can see, it's got a DVI connector at the back. That's for a Sophia 2, which I installed late last November or December, something like that. So about 4 months ago, I installed Sophia, I think Ultimate 1 megabyte and UAV as well. UAV is a legacy video upgrade, so pertaining to the legacy video socket here. Obviously Sophia is a GTIA replacement, which provides a number of different digital and analog video formats, among them DVI, which is the one most people tend to go with. It'll also output 15 kilohertz RGB VGA component, something else I think. And I've put an audio jack here just for mono audio, just so that you can actually tap the audio off without using a special cable when you're using the DVI output, which all works very nicely. Before we continue, I'd like to say a few words about this video's sponsor, PCBWay. Now, PCBWay have over 10 years of experience in the field of PCB prototyping and manufacture. Not only that, but they offer CNC machining services and 3D printing. And since you're watching this video, I assume you're interested in 8-bit Ataris, and if you head over to the PCBWay community section, you can find a whole host of interesting designs for those computers, including the 1200XL extender cart and even a 3D printed case for the Atari 1090XL. So if you need a prototype PCB, or you could use any of the other services on offer, pop down to PCBWay.com today. I've actually done the casework twice on this machine because there was a little bit of confusion. When the machine was originally sent up, it was sent up not with its original bottom case. And I don't know, maybe the owner was a little bit unclear about the work that had to be done to accommodate the DVI connector on the back. But anyway, he had second thoughts about the case, so he kindly anyway donated me the spare machine that the other bottom case came from, and I've got the original bottom case that was now on the other machine, and I did the work again on the back, and so now it's all the plastic parts are from the same case anyway. So the problem is, I'll use one of the videos that the client sent to me, which actually shows the issue in action. When he got the machine back for the first time, he was playing a game, I forget which game it was, probably Drop Zone or something like that. Oh no, it was Atari Blast, I think. And after he'd played it on a big flat screen TV in the living room for an hour or two, he noticed that the video would periodically drop out and just go black. And then it would come back, or the machine would even appear to crash, which I thought was very, very strange. Never had problems like this. Well, I say never had problems like this with Sophia. I had a problem with a stray sort of pixel interference issue, but that was years and years ago. I think it was a Sophia 1. Simius very, very quickly fixed that problem with a firmware update that he sent to me. And I've seen another couple of threads on Atari Age where people have had something similar, sort of video dropouts and stuff, and there've been various theories about what might have caused it. I think one of the threads I looked at the other day didn't seem to have been resolved, or not in a front-facing manner anyway. We'll take it apart anyway, and I'll continue to opine about the details. He sent the machine back here so I can have a look, because I speculated, I've been having a bit of experience with issues like this in the past, that it might actually be a phase 2 clock problem. So that was causing the Sophia, which completely replaces the GTIA chip, don't forget, and therefore takes over all GTIA video processing duties that might have had a bit of a synchronization issue anyway. So I had a look at it and actually swapped the 74LS08 chip. I think I put an F08 chip in. Either that, or I took the 74F08 chip that I'd already put in. I think this is what happened. I took the 74F08 chip that I had put in to pre-arm the computer against, should you ever want to put a side 3 in it, for example. I think I took that out and replaced it with the original, or an original 74LS08 chip, just because I thought that might fix the issue. But the testing to evaluate whether the issue was present or fixed takes ages. And I remember on one Wednesday I sat here, because I tend to go out late on a Wednesday afternoon, I sat here, sort of doing other things obviously, but with the Atari Blast game running in demo mode, trying to observe this problem, and then doing the modification, and then trying to observe the problem again. Obviously I wanted to reproduce the issue here to make sure it wasn't some issue with the power supply localized to the customer's house. But very, very time consuming when an issue takes that long to show up, but I could reproduce it. And of course this saga's been going on for so long now that I actually became a little bit unclear about what had been done. But I think I was able to replicate video dropout on the Legacy channel as well. Now later on there was a little bit of discussion about that. The customer was also, as well as the flat screen TVs which he's using with the DVI connector via a DVI HDMI cable, he also has a Philips CM8833 Mark II, I think, and obviously he hooks that up to the computer via the Legacy monitor port, probably composite I would imagine, because unless you've modified your Philips CM8833 Mark II for S-Video, separate Luma and Chroma, as I have, and there's a video on that from years ago if you want to watch it, you won't be able to get anything but composite input. So in any case, he was observing the same issue on the composite picture, which I thought was interesting, because we'd had a lot of speculation about maybe one of his TVs had a timing issue with a compatibility issue with the DVI signal, which seemed quite a plausible explanation, but not if the problem also exists on the Legacy output. That implies some sort of, a problem right at the source, right at the GTIA position, where the separate luminance and colour signals originate on the video bus itself going to the Legacy monitor jack. Of course, I suggested that he involve Simius in this discussion as well, which he did. I wasn't originally directly present in the discussion he was having with Simius, but Simius had speculated that it could actually be a broadband interference issue from the CPU interacting with Sophia, because after I did this timing fix on the machine anyway, it did nothing. It didn't fix the issue. So that was the first return visit this machine had made to me. And yes, I have put the original 74LS08 chip back in. So when I did that and sent it back, because it seemed to me that it fixed the issue, it hadn't. So then we got Simius involved, and Simius thought it might be broadband interference from the CPU. So anyway, what Simius kindly offered was that if the customer returned just the Sophia board to him, he'd have a look at it, because he had a couple of ideas about what the problem could be, and he'd look at it, have a look at it, see if he could fix it up, and then send it back, which he did. And that happened in sort of late January, I think, this year, early February. And then the customer told me that the Sophia had come back. Apparently Simius was able to reproduce what he thought was the same issue on one of his displays. So he set about addressing that problem. I don't quite know what he did to address it, but he addressed that problem and returned the board, thinking that that would hopefully resolve the client's issue. And the client got it back, and unfortunately, because he's not an expert in these things, he managed to misalign the UAV board and plug the Ultimate 1 megabyte header in back to front when he was putting everything back, because he'd actually removed the Ultimate 1 megabyte inadvertently when he was getting ready to uninstall the Sophia, and this UAV was positioned one pin too far along in the socket, because he didn't realise he'd done this. So when he got the Sophia back in the machine, there was no picture at all. Basically the computer wouldn't boot, especially owing to this cable being the wrong way around. I didn't realise he'd made this mistake, so I said, well, you can send the machine back. So it came here for a third time. Obviously I immediately identified the smoking gun issues, real smoking gun issue. I mean, you're never going to get a picture of the UAVs not properly in the socket, and you're never going to get a booting machine if the phase 2 clock signal is in the halt pin and the etc, everything was backwards. So I fixed that, and I did do a sort of perfunctory test of Atari Blast to see if the issue would show up after an hour or so. I didn't notice any problem at all, so I sent the machine back thinking that that was the end of the story, and that was, what was that, middle of March or something? And anyway, so at first it looked like it had actually fixed the issue when the customer got it back, but after an hour or two, the same thing happened. So it hadn't fixed the issue. So then I suggested that the customer bring me into what would now be a 3-way conversation with Simius, and we had a bit of a chat about it. Now, I have to admit, I was getting kind of tired of it after 4 months. I mean, I think this was a £120 installation job here, and I mean, in terms of time spent, fortunately I haven't got much work on at the minute, but in terms of time spent, any profit has been completely obliterated, which isn't particularly unusual these days, owing to the number of problems I encounter on a routine basis when doing what used to be very, very mundane work. But that's another matter entirely. So I asked Simius for some clarity as to exactly what he had tested when he got the board back. And it looks like what Simius observed was actually confined to the DVI signal, which we hadn't been sort of clear about at the time. So really it was kind of a secondary issue that he kind of picked up on, whether it's common to this board or all boards, I don't know, but clearly the focus was in the wrong place, so that's not really anybody's fault. That's just a sort of lack of clear communication. But once I was on the scene, we eventually got rid of that ambiguity. So anyway, Simius was speculating. I mean, he's blessed, he's trying to think what it could be. And fairly reasonably, he said, well, what about the socket that the GTIA, or the Sophia, is actually in? As far as I can remember, when I tested the machine with an original GTIA chip in it, using obviously the legacy output, I couldn't see a problem at all. But I mean, that might have just been a fluke, so I'm quite prepared to accept that. The annoying thing is that when Simius said that he could duplicate what he thought was the primary issue at his house, immediately I think, well, the problem is travelling with the board. The problem is not the host board. The problem must be travelling with that Sophia board all the way back to Poland so he can reproduce it in one of his machines. So the focus is therefore taken away from a potential issue on the host machine, and it's focused on the Sophia board. Now we know the full facts of the matter, that this board hasn't really been tested in a different machine with a view to observing the primary issue. Then the onus comes back on me. And anyway, Simius said, well, what about the GTIA socket? And I said, well, I can't remember, it's that long ago. If GTIA wasn't in a socket, I'll put a precision socket in. If it was in a socket, and sometimes they are out of the factory because I think they actually had problems at the factory and they often had to swap the GTIA chip, more than likely I just put the Sophia chip straight into the factory machine socket. The thinking there is, well, it's manifold, in fact. Cost effectiveness in terms of time, because removing a socket that's only had a chip plugged into it once or twice in its entire 40-year lifetime, it seems to me that it's not really necessary unless there seemed to be anything obviously wrong with the socket. Now, Sophia is a nice, lovely, snug fit, I found anyway, in these machine sockets. So that was another reason that I kind of thought, well, we'll just leave well alone. And actually, I don't think the Sophia was particularly well pushed home there, but that could equally be my fault. But we need to eliminate all the possible causes of the issue. So to that end, what I've agreed to do is take off this old machine socket from the board and replace it with a nice new precision socket. And while I'm about it, I'm going to have a look at some of the electrolytic caps on the board, just in case we've got some sort of power related issue, which is something else Simius mentioned, and he's quite right to do so. So we'll check out all that stuff. But the first thing I'm going to do is get rid of this factory machine socket, and I'll give you a closer look at it when I get the Sophia out of the board. So here we are, this is the machine socket. It's dual wipe as far as I can see, and I can't see, maybe there's some oxidization on it, I don't know. It's possible that pin at the bottom looks a bit dull. That one, which one's that, pin 8? Pin 8 there, looks a bit dull. That one from the side angle, that looks a little bit dull as well, so we might have some oxidization issues there. Possible. But let's get rid of it and see what happens. I've already put a socket under this CD4050 here. I put a socket under the MMU, I put a socket under the OS ROM. We'll check all of them as well, make sure that nothing's been missed, make sure we haven't got any dry joints. It'd be well worth doing that. We'll go over the whole thing, and by the end of it, we can eliminate the sockets as a potential cause of problems. Better yet, I mean, not good from my point of view, but as far as being implicated in the issue, but better yet if I can actually replace the GTIA socket or do something else to the board and I just find that it has definitively fixed the problem. I mean, it's not a contest as to who can get blamed for the problem. We just want the problem fixed at the end of the day. And we know that communication issues resulted in the focus moving away from the host machine. It may turn out that replacing this socket does nothing at all. I'm going to turn on the desoldering machine, I'm going to turn on the hot air, and I'm going to turn on the soldering iron, and I'm going to wet the bottom of this board here. I'm going to get me magnifier out because I can't really do anything without that, and I'm going to have to move this camera a little bit. Okay, so let's wet the bottom of the socket, and I'm going to be looking all over the board now for potential defects. Now make sure I get the right socket as well, don't forget it's the front one here. So I'm going to wet it. Will Wheaton. Yes, Will Wheaton.
Yes, Will Wheaton.
Why are you saying it like that?
Well, I'm just saying you should be nicer to Will Wheaton. Will Wheaton seems like a nice guy.
Can't see anything wrong with the underside of it. There's no cracked joints or anything, but it's coming off. It's a higher risk operation, even for the best of us, because you've got an increased chance, obviously depending on how robust the motherboard is, and a lot of the XE ones are not robust at all. You've got a higher chance if you're not very, very careful of ripping up a trace or pulling out some through-hole plate or what have you. Now I can do that, not that I do it very often, but sometimes it happens and I can't help it. Now I can fix things like that and I can notice them and fix them before they cause an issue. But for a lot of people it's not so easy, so you really have to be super, super careful. So hopefully my desoldering gun is going to play the game today. I actually like to do this upright, so we've got a really weird angle here. Right, apologies if this isn't completely in focus, but it's the best I can do. This is a weird angle and I've got to use the magnifier. Or do I have to use the magnifier? Surely to Christ I can see this. Let's try it. Right, here we go. Is this the right chip? Yes. So if you hold it upright like this, you're letting gravity help a little bit. And hopefully it'll be a little bit easier, because it's not pulling the solder up vertically, it's pulling it up horizontally, of course. And what normally happens with this desoldering tool is that every time you want to use it, it doesn't work because it's blocked. Now, I've bought about 4 of these handsets for this thing. Obviously the base unit's fine, just have to replace the filters now and again. But I'm on my 4th or 5th handset with these, and the handsets are about, what, 15 quid or something? 20 quid? It's still more cost effective to just keep buying handsets when they become irredeemably blocked up than it would be to spend 400 odd quid on the Hakko desoldering station. I'm still well short of spending that amount of money, and of course the way things are at the moment, I'm not even sure I can justify spending the extra money on a tool which I may only end up using a handful of times per year, because nobody's buying any upgrades and nobody's sending any machines in to get repaired. Now sockets as well, especially this type, they don't have much clearance on the top side of the board, so there isn't really much airflow when the desoldering gun is trying to yank the solder out of the socket, which makes it even more difficult. And yes, I do have the heat on this thing turned up to the maximum because anything else just doesn't work for me. So let's go add more flux, and we're going to go in hard with the desoldering braid. I'll do the best I can to just clear these holes here. This camera angle isn't too bad actually. It means that I can use my little spyglass and you can still see what's going on, so maybe we'll use this more often in the future. So I'm just trying to get everything out of the holes here so that it releases the pins, because obviously they'll tend to attach to the sides of the plate through area on the board. You don't want them to still be doing that when you try to yank the socket out, because in that situation then you find that there's a via still attached to the leg of the socket of the chip, when you get it clear of the board, and it's never a happy time. And often there'll be a trace dangling off it as well, and it's just not good. So we're not doing too badly here. Obviously I'm going to go over the other row as well, just to make sure they're all released. Remarkably versatile, this camera boom, it has to be said. Right, it's kind of going. I'm going to now add heat. There we go. Wasn't pretty, but it's off. Now I'm going to go and pull the rest of the bits off here. Yank the rest of these legs out. Hopefully without any difficulty. Alright. That didn't look too bad at all. But I'm basically deburring the vias here. Just getting the little sharp edges and bits and bobs of solder that's left on here. Right, and the holes appear to be all clear, so I'll do the back side of the board as well. Make sure it's nice and smooth. Now there's one that's got a bit of solder in it there, so we'll get that one. And that's pretty much the sole drawback of using loads and loads of flux, as I like to do, is cleaning the damn stuff up after the fact. And I can visually tell that there's nothing damaged on the underside. Where I'm more concerned is on the top side, because this will become completely inaccessible once the new socket's put in place. So it's absolutely vital that you catch any damage to vias or traces at this stage before you put the socket on. And if that means doing a continuity test with the multimeter on all the traces, so be it. So this is the board following removal of the socket. As you can see, all nice and clean, all nice and perfect. We've got no damage. We haven't even really brought the solder mask off to any great extent anywhere. I was poking around with a screwdriver. So that's all going to work nicely. But I'm really going to look very, very closely at that, because we don't want to find that we've got some micro cracks and any traces that are opening up when things warm up a little bit. So I'm going to continue to check that out. But yeah, I'm very happy with that. Nice to be doing some soldering actually. I haven't really had occasion to do any for about 3 months. Right, so I'll go and grab a socket and we'll put it in. So even if this replacement socket has an issue, it's not going to be the same issue as we had with the old one, if the old one had an issue. So I'm going to do the corners and then just push from the other side, being careful not to burn myself, just to make sure it's on flat. And if you're wondering why after when I cleaned all the flux off the board I haven't applied more flux before doing this part, well, of course this is cord solder which has flux built into it, and it still leaves quite a reasonable amount of residue on the board. And what I'm really looking for, hopefully I'll be able to, if the issue still exists, hopefully I'll be able to replicate it and document it on video. But what I'm really hoping for, what I'm looking for initially is just as long as the machine still works with the new socket in it. Even if the client runs into the problem, even if I haven't been able to reproduce it, so I missed it, because I haven't really got time to sit here for 2 and 3 hours at a time playing Atari Blast on the off chance that this issue crops up. At least if he runs into it after the fact, then Simius knows that I've addressed any potential issues with the motherboard, and if he has to, he can send the board back to Simius again. I'm checking for any solder flex, or that's a factory bodge there where we've got bits of trace hanging off. That was cut at the factory and replaced with that pink bodge wire, so I'm just going to scrape that stuff off there. There's a funny looking resistor there. I don't know what the hell that is. Didn't notice that before. So what's that on the top side? Third one from the right. It's oh, somebody's changed a component on the motherboard. They've removed C206 and they've put a, I don't know what the value of that one is, in place of the L. So they've replaced an inductor with a, somebody's done a video mod on this machine. Of course, it doesn't make any difference because it's got UAV in it now, so all this circuitry is completely bypassed. But I'm just going to touch up that solder joint nevertheless because I don't like the look of it. Trying to find one of these computers that hasn't been messed on with in some way, shape or form already is an absolute exercise in futility. It really is. I mean, the one that he's completely removed, he hasn't removed, he's just snipped it off. It's always a bad sign when somebody's wanted to remove a component and instead of desoldering it, they just snipped it off at the legs, because that just implies that they haven't got the know-how to do the job properly. Let's see what people have been doing on the top side of the board. I just hate the fact that all of these computers have been faffed on with at some point. And of course we've got a video issue, and what was messed on with by somebody else in the past? The fucking video circuit. There's a blob of solder here, but it doesn't look like it's doing any harm. You see, I just don't know. It could be anything. It could be something somebody has done to this board that isn't apparent, but it's been pre-broken. There we go. Now, is that sitting flat? That's sitting nicely. I'm happy with that. Right. The owner has the keyboard stuck to the top case for some reasons of aesthetics as well, by the way, if you're wondering why it isn't coming off. So we'll go with the DVI connection here, and I'll plug in my audio cable. And I'm going to go with the venerable side 3.0. Okay, so here we are. We've got, let's look for Atari Blast. Did I see it there? Yes. Car. That'll do. Okay, we've got a nice picture. I'm going to leave this camera running for potentially the next hour or more, just to see if we can replicate the issue. Because the issue was observable on this display, and this display is absolutely bulletproof. It's a fantastic retro screen. Okay, so after an hour of running the Atari Blast demo mode, the issue showed up right on cue, almost exactly after an hour. So the screen blanks out initially, and when the image returns, the game has mysteriously gone into pause mode with some GTIA player missile graphic garbage running up and down the left-hand side of the screen. And interestingly enough, the start key triggers the pause mode in the game, and of course the GTIA chip, or in this case the Sophia 2, handles the start key. Now, subsequent to this, I just ran through a list of tests designed to narrow down the problem, and the first thing I did was put the original GTIA chip, or a GTIA chip that was known to work, back into the client's machine, and then ran Atari Blast again in demo mode for well over an hour on 2 separate occasions with that original IC, and there was no problem whatsoever. So what I then did, remembering that I had another Sophia 2 in my 1088XEL, I swapped that Sophia board into the client's machine, and sure enough, the problem happened again. Then conducted the reverse test, which was using the client's problematic Sophia 2 in the 1088XEL, from which I'd taken the other Sophia 2, and the problem did not occur on that machine. So on the face of it, that did suggest that there was a problem with the 130XE, but the question was, what could it possibly be? So bearing in mind that the Freddy chip on the XE series supplies the clock signal to the GTIA chip, I decided to socket and replace the Freddy chip. Right, so well over an hour into this test, I've put a socket under the Freddy chip, taken the original Freddy out, which was an NCR, and put another NCR branded chip in the socket, which I'll show you here. So this one here, I've put this one in, so that's the original chip, and this is the one I've put in here. Of course, that involves putting a socket under it, so maybe maybe there was something going on with the soldering on the original chip. So it's the same EA chip, but it's got different markings on it, so it obviously comes from a different fab by the look of it, totally different. And it looks like the problem has not appeared, but the problem is that I've still got my Sophia board in the computer. Now you can see I've had the oscilloscope out here, Simius suggested that this could be a PLL issue, which is a phase-locked loop. Now, there are two such chips, ICS 570 chips, on the Sophia board. They take the 3.5 megahertz signal from Freddy. So there we go, that's 3.546 to 3.55 megahertz coming from the OSC pin on the Freddy chip. I know you can't really see that. I'll aim a camera at the scope. Right, so what I'm measuring here is pin 37 of the Freddy chip, and that is a 3.546 to 3.55 megahertz clock signal. So that's the OSC pin. And if we measure the input on pin 4 to the left hand PLL of the Sophia 2, being careful not to bloody bridge anything with the probe, we can see that that is a identical 3.546 to 3.55 megahertz signal. That's in the bottom left hand side of the scope's display. The input on the other PLL is half that. The output on the first left hand PLL, not measurable. While I was trying to probe them, I accidentally bridged two pins of the PLL. That upset it, and that gave us the exact issue that we've been observing, which was the Atari Blast jumping into pause mode. So in any case, what that shows us is that if the PLL goes out of lock, which it does if you slip with a probe and bridge both output pins, because the pin 7 is supposed to be half the frequency of pin 8, it triggers pretty much the exact problem that we've seen previously. So it leads me to believe that Simius is absolutely correct, and that the PLL is losing the lock on the OSC signal, and that's what's causing the trouble. Now, I haven't been able to observe that problem since I replaced the Freddy chip, but I was able to trigger it just by messing up the output from the PLL. So what I'm going to do now is turn the machine off. I'm going to put the original Sophia back in the board, and the hope is that I don't observe the issue there either, because the issue was reproducible with my Sophia, which I'm now taking out of the board. The two Sophias are there, therefore both display the issue, not in an identical fashion, but it's reproducible on both boards. Therefore, if it was fixed on my board, perhaps it's also been fixed on the original board. Right, so that's going to go off into demo mode. So I'll turn the camera off for about an hour and then come back and we'll see if the problem crops up with the original Sophia. So what I've done here is I've actually put a socket under the Antic chip and swapped it out for a different IC. That's the original Antic chip. The markings have more or less disappeared on it. The reason for this, and it may be completely irrational, and I'm sure it is, and I'm sure anybody with deeper understanding will just say it's bullshit, basically. I felt the CPU was getting ridiculously hot anyway. I know that the Antic chip essentially bus masters the whole system, and of course it's got the capability to halt the CPU. And of course when the CPU's taken off the bus, depending on what state it's actually in, it can get a little bit hot. But of course you might say that if it was actually taken off the bus, the demo wouldn't be running at all, the game wouldn't be working. There's absolute logic in that, so what I'm saying, I might be talking absolute nonsense here, but nevertheless I put a socket under the Antic chip and I swapped it out for a different Antic chip. And in the meantime as well, Simius got back to us and told me that the right hand PLL is used just for colour encoding, so it's the left one we're going to look at, and he told me the frequency that it should be actually running at on the output of the left PLL, and it should be 56.75 megahertz, I think he said. So we're obviously in the range there. I think the bounce that you're seeing on there is just the probe. So there we've got 56.82, 56.66. I'm assuming the fluctuations are just measurement errors. The reason I couldn't measure this before is I didn't have the probe on times 10. And now I've done that, of course, I can measure this properly. And I mean, it looks reasonably consistent. And the other thing that's kind of encouraging is, I mean, this has been running for well over an hour now, and I haven't seen a problem yet. Before I changed the Antic chip, I found that I could, ironically enough, I could trigger the problem almost immediately just by blasting the CPU, or the CPU area, but actually aiming the hot air at the CPU and heating it up to pretty much where it was when the problem cropped up, which was fairly hot, and the game would immediately go into pause mode with the player missile graphics crap running down the screen, just as we saw, and normally have to wait around for an hour for that to happen, which I found very interesting, and that's basically why I decided to replace the Antic chip. Now, I tried that same trick after putting this Antic chip in the board, heated it up, and I've just tried it again just before I clicked record, and nothing happened. This is puzzling. Obviously, it's too early to call it yet. We know for a fact that the PLL was losing the lock on the oscillator frequency, so and because I found that forcing that to happen does determinately cause the issue. So if you have some insight on that, feel free to post it in the comments below, unless we hear some more definitive information or theories from Simius in the meantime, which we did. The last thing Simius said in the conversation, after I told him that I'd replaced the Antic chip and it did appear to fix the issue, was Antic has no connection with OSC, which is the clock signal coming straight from the Freddy chip. So the only way is a conducted emission, and that's if OSC interference is even a concern. If replacing Antic solves the problem, there may also be some anomaly in the ANX generation that the stock GTIA may have a greater tolerance for. So that would be the actual graphical data being sent from the Antic chip to GTIA. I think what he's suggesting there is that basically got scrambled up somehow and causing a loss of video. However, since we saw Sophia 2 losing the lock on the OSC signal when we tested it with the oscilloscope, I don't see how it really correlates with there being an ANX generation issue on Antic. So obviously I'll be putting the machine back in the case, testing it again, testing it again, testing it again. But even if this is somehow fixed, I'm not sure yet whether this video is going to have more footage on the end of it for one reason or another. But the client would actually like to get RGB video out of this DVI port here. Now, of course, it's a DVI-I port, and it does have the VGA signal or the RGB signal, which can be VGA on the analog pins. And I've just had a look to see if I can get an open DVI connector for soldering, and I can. So what I'm thinking of doing is building a DVI to DB9 cable, because he wants to plug it into the back of a Philips CRT monitor that wants 15 kilohertz RGB. Obviously we can make a special cable. You can buy a headphone to twin RCA cable for the audio, that'd be no problem. But I think if we just make a DVI-I, so I'm just going to wire up the 4 analog pinouts RGB and sync, and then run that to a DB9 connector at the other end of the cable, that should enable him to plug this into his Philips monitor. Of course, he'll have to go into the Ultimate 1 megabyte plugin or the Sophia configuration tool. The plugin will probably be more convenient, and just switch the RGB mode to 15 kilohertz, or to turn VGA off. I can't remember exactly what you have to do, so I've stopped the test, so I'm going to have to run the test again later on. So yeah, we've got VGA DVI resolution, we've got VGate, we've got blah 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 blah. Right, so RGB output, we've got C-Sync, VGA, horizontal, vertical sync, so it's quite flexible. I think this is going to put out a 15 kilohertz horizontal sync, which is basically SCART compatible. So if he has it in that mode anyway, that would be handy if this can be set up just so that the RGB always runs. I should take these off as well out of this plugin. It's not really necessary. If you can just leave it like this, maybe the analog pins are currently outputting a suitable 15 kilohertz sync signal. We'll see when the time comes, but hopefully if the problem has been fixed, then we can get on with that, and that would be quite an interesting thing to run the Philips CRT monitor off this connector here, and that would give him the best of both worlds. So basically the conclusion of this video should be, if you install Sophia 2 and you get this kind of thing. There was already a thread about LDO regulators as well somewhere on the Atari forum. So there's 2 things you want to be looking at as far as I can tell here. Clock signals and power. So obviously, I don't know if the Sophia actually draws more power than a GTI chip. But first thing to be checking for, I would have thought, would be check the power rails, make sure you've got no swollen caps or anything. So interruptions to the power in the GTI socket are going to be problematic. Check your power supply, etc, etc. In addition to that, when the whole system warms up, what we've seen here is that the clock signal was going off outside of the margin of error that Sophia could cope with by the looks of it. The original GTI chip didn't seem to mind because the machine we know the machine worked perfectly before the Sophia was fitted. The owner was playing games on it in stock condition and never had a problem. And we know that this issue is affecting the whole video bus, not just DVI output. I did try replacing the Freddy chip earlier on. That didn't do anything. I've even had the oscillator package off the board. I was going to actually replace it, but I couldn't find one, so I put this one back. I tried a different CPU. I've actually put a 74F08 in the machine again. It was originally fitted with one. I took it back out and I've put it back. I don't think it makes any difference, but it just means the BO2 phase 2 clock is just going to be a little bit cleaner, a little bit more responsive, which is handy for things like Side 3 should you ever choose to use it. It doesn't seem to regressively affect anything else, certainly not Sophia, because that's running straight off the oscillator signal from the Freddy chip. And ultimately we've replaced the Antic chip here, and that may have made a difference. So we'll assume it has. If it hasn't made a difference, this won't be the end of the video and you probably won't be seeing this bit at all, but if that helps somebody who's had a problem, that's all for the good. But yeah, I hope you found it interesting. I'm on day 2 of this since the machine came back here for the 4th time, and the client has acknowledged that he's going to need to pay something for my time here because the problem obviously isn't caused by any oversights in the installation or anything like that. It's just one of those things, and it's becoming increasingly difficult to track down problems with these machines because so many of them been messed around with. They're in such a decrepit state in some cases now that you really need to get your thinking cap on when trying to figure out stuff like this. I even tried a different Ultimate 1MB in absolute utter desperation. Wouldn't it have been amusing if it was the newer revisions of that board that were responsible for this somehow? But no, they weren't, because this older board, I tested that and it was exactly the same. Yeah, so thanks very much for watching. Thank you to the patrons as always. Thank you to the video sponsor. With fingers crossed that this is it, because the poor client is just at the end of his tether, and of course I'm right at the limit of my skill set here with the oscilloscope out and trying to diagnose problems with PLL chips. So thank you very much for watching again, and with a bit of luck, if you've enjoyed it, I will see you in the next video. So bye bye for now.